Hey guys, my name is Dan Changfaran, student ID 0369793. The topic for our lab assessment is social media usage and well-being. Our project objective is to analyze social media usage trends and interaction across different platforms. This dataset helps in identifying behavior patterns, engagement levels, and dominant emotion based on user demographics and activity metrics. Next is the data source. This dataset used in this project is titled as Social Media and Wellbeing and was obtained from Kaggle, one of the leading platform for data science and machine learning. This dataset was created by Ermil Bulut, a recognized AI inventor, and is licensed under Massachusetts Institute of Technology (MIT) with an exceptional usability score of 10.0. Next is the overview of the data. This dataset contains information about 1,000 users, including their demographics, which is age, gender, and platform. Next is social media metrics, which includes daily usage time, post per day, like received, comment received, and message sent. And lastly, psychological metric, which include the dominant emotion associated with the user's activity. Next is type of variables and level measurement. First sub is numerical variables, which includes age, daily usage time, post per day, likes received per day, comments received per day, and message sent per day. And of their level measurement is ratio. Next is categorical variable, which includes user ID, gender, platform, and dominant emotion, where user ID uses unique identifier for its level measurement, where the others uses categories for their level measurements. That's all for the introduction. We're moving on to descriptive statistics. So we start off with reading the file with read.csv. As you can see, the file is read. Next, we'll be running head to get the first 6 rows of the dataset. And next, we'll go for tails to get the last 6 rows of the datasets. We then get the number of rows, which you can see here is 1,000. Then we'll get the number of column, which is 10. Next is code name for column names. And next is structure. You can see it prints out the structure of dataset, which shows column names, data type, and first few rows. And lastly, we'll do summary of our dataset, which shows the minimum, first quartile, median, mean, third quartile, and maximum of numerical data, and length class mode for categorical data. That's all for my part. I'll pass you on to Tang Zixiang.
Hello everyone, my name is Dang Zhixiang, my student ID is 0361451, and I'm going to talk the issue of the dataset. And first of all, we need to ensure we have the library, and also we have the dataset ready. And the first issue that we're going to talk is the missing value. So we can use this of the code to detect which row they are missing value, and we see their all numerical value, so we can combine it into a numerical column. And also we can run a for loop to replace them with the mean value, and then we update the loop again to see whether there has been successful update or not. Yeah, the successful update. The next is the typical row. So we can use this code to display number of row. There are typical row, 10 row. Which row they are? We can see these are the row are typical rows. Then we can remove them, and we can see again the total row. Yeah, they have been removed away because 10 row and we have the 1000 row dataset. Next is the outliner. So we can, because we have the multiple plot, and also we can use back the numerical column because detect outliner in numerical value already only. Then we can use the code to put all the diagram together and see. Yeah, there are one is extreme to the queue, and also some get detected is keep repeating, so we can ignore this, and we can use this code to remove and calculate the total load again. It's 989, so we confirm they are have been removed, and then the improvement is we need to increase the memory efficiency and better for analysis and easy grouping, so we can combine the category column together, and then change them to the vector, and also we can use the structure to confirm their change ID. Then we can use this over the code to see their summary, their table of the column. That's all for me. Thank you.
My name is Chia Yi Hang, student ID 03699785. Right now, I'll be talking about the graphical explanatory analysis of our datasets. We've used three graphs to analyze the key variables and also their relationships, which are the first bar plot, the second one is a box plot, and the third one is a scatter plot. We arrange them in a grid layout. Okay, as you can see here, the first graph is a bar plot. It shows the distribution of the number of posts made per day by the users. From the graph, we can see that majority of the users post less than 2 times per day, with a sharp decline in the number of users posting more frequently. This right-skewed pattern suggests that most users are not very active in posting, while only a small portion contribute a higher number of posts daily. Moving on to the second graph, which is a box plot, it examines the distribution of a daily social media usage time across different age groups. From the plot, we observe that younger age group, particularly those aged 19 to 25, have the highest median usage time, with several outliers representing excessive usage. In contrast, older age groups like those over 50 show significantly lower usage time and a narrower range. Last but not least, our third graph, the scatter plot, we explore the relationship between the number of likes and comments received per day. You can see a positive correlation between likes and comments, as users who receive more likes, they tend to receive more comments as well. The linear trend line reinforces this relationship, showing a steady increase in comments as like increase. That's all from my side, and this will be the end for our group presentation for this lab assessment. Thank you.